Hello everyone, welcome you all. In this video we are going to see adiabatic process and we are going to derive this law PV power gamma is equals to constant. So now what is adiabatic process? The process in which there is a no heat transfer between the system and the surrounding. Such a process is known as adiabatic process. Means what? I will give an example. Now consider this is the thermos flask, okay? So now the thermos flask generally used to keep the liquid at desired temperature. So consider the inside fluid is at high temperature, greater than the atmospheric temperature. Okay. So now there is a no heat transfer between the fluid which is present inside the thermos flask and the surrounding. Okay. So such a process is called adiabatic process. Means there is a no heat transfer between system and the surroundings. Okay. So such process is known as adiabatic process. Okay. And one more thing. For adiabatic process to take place, the system should be thermally insulated. Okay, then only the adiabatic process takes place. The system should be thermally insulated in order to take the adiabatic process, because there should no heat transfer between system and surrounding. Okay, so this is about the adiabatic process. Now coming back to the relation PV power gamma is equals to constant. So now we consider non-energy energy equation or the differential equation of the first law of thermodynamics. I can write dq is equals to du plus dw. Okay, we have already discussed this about in previous video. So what is dw? Dw is the amount of work done by the reversible process. So I can write dw as p into dv. We have already derived this relation. Okay, so I substitute here. What I get, dq is equals to du plus p into dv. This is my equation number 1. Okay, so now as adiabatic process, this dq is change in heat transfer is equals to 0 because there is no heat transfer. Okay, now du is change in internal energy. It can be written as cv into dt. Okay, so now here pressure I can be write from ideal gas equation, that is pv is equals to RT. From here I can write P as RT divided by V. Okay, if I substitute these three values in equation number 1, what I get, dq is 0, which equals to du is cv into dt plus this pressure I can write RT by V into this dV. Okay, so now I have to remove this t. So what I will do, I will divide throughout the equation by t. Divide by t on both sides. So what I get, if I divide t, 0 by something will be 0, which is equals to, so now this cv, this dt by t, I am dividing by t here, this t and this t get cancel out. What I left with r into dv by v, which is equals to 0 by something will be 0. Okay, now this is the so equation. I will mark it as equation number 2. Now what I will do, I will integrate this equation. Okay, integrating on both sides. So this cv is constant as it is. Integration I can write 1 by t into dt plus this r also constant. Integration of 1 by v into dv, which is equals to 0. So I can write this cv as it is. Integration of 1 by t with respect to t will be log t, log to the base e t, and plus integration constant c1 I will write this plus r. Now 1 by v with respect to the integration of 1 by v with respect to v will be log v, and plus integration constant c2, which is equals to 0. Now this c1 is also constant, c2 is also constant. If I take this constant that side, it will be also a constant. So I will write this equation as cv log to the base et plus r log to the base v is equals to constant. So I have taken the c1 c2 constant, that side will become a constant. Okay, so now what I will do now, I will divide this equation again with cv. Okay, divide by cv on both sides. So why I got CV will cancel out, left out with log to the base log t to the base e, plus here I am dividing with CV log e to the base log v to the base e, and is equals to this constant, and CV also is constant. Constant divided by constant, again I get constant. Okay, so now there is a relation for CV. We know that CV is equals to R divided by gamma minus 1. Okay, so if I rearrange the term, if I take CV that side in the denominator and I take gamma minus 1 in the numerator, so what I get, this CV in denominator, R by CV, this equals to this gamma minus 1 in numerator. So I have rearranged the term here, this CV in the denominator and gamma minus 1 in the numerator. So I will replace this R by CV with gamma minus 1. So what I get, this log t to the base e, plus here in the place of R by CV I can write gamma minus 1 log v to the base e is equals to constant. Okay, so now here you can see m log a. M log a formula is log a power m. So I can write this as log m log a can be written as log a power m. Okay, so now log a plus log b is nothing but log a into b. So I can write log t into v ki power of gamma minus 1, which is equals to constant. Okay, so now this t, how can I write t from this ideal gas equation? From this I can write t here, PV is equals to RT. If I bring R this side, so T is equals to PV by R. Okay, I will substitute this value here. So what I get, log this T I can write PV by R into V ki power of gamma minus 1, which is equals to constant. Okay, so now this, if I take log that side, it will become e raised to, and here bases are same, power should be added. Here power is 1, so gamma minus 1 plus 1, this minus 1 and plus 1 get cancel out. What I left with gamma. So if I take e that side, it will become e raised to. So this p by r, now v ki power of this gamma minus 1, okay, plus 1, bases are same, power should be added. Okay, so now e raised to constant. So now this plus 1 minus 1 cancel out. So what I get, PV power gamma is equals divided by R. So constant, e raised to constant is also a constant value. So if I take R that side, PV power gamma is equals to R into constant. So here R is also constant and constant. If you multiply by constant, we get again constant. So PV power gamma is equals to constant. This is the adiabatic law. Okay, here gamma is known as adiabatic index or adiabatic constant. For diatomic gases like oxygen, nitrogen, gamma value is 1.4. Okay, thank you.